as we continue on to section 2 of chapter 2. This is where we actually look at starting to solve equations. So we'll be going through these learning objectives. And again, we'll mention some word phrases as algebraic expressions. But as background, to get us started in solving equations, I often use the example of a scale or a teeter board, a seesaw, in which there is the middle and a certain distance from the middle on this end, and that same distance we have a weight that's exactly the same. So this board is balanced. And in a sense, we can put like an equal sign there, indicating that what's on this side equals what's on this side. Now, if I take this and divide it into two parts, and then take one part away from this side, it's not going to balance anymore. But if I take that same part away from the other side, it's not the same amount anymore, but it still balances. And if we take more away, from each side, let's get the eraser here. Again, it's not what we started off with, but it still balances. And what we're looking for is that left on this side will be a letter X, and on this side will be a number 3. So we're saying now that this X, this unknown, equals 3. And we did that through a series of manipulations, computations, in which we get apart whatever was over here, so there's only an X left on this side, and then a number on this side. So the series of steps that we do to get to this point are referred to as solving an equation. And that's what we'll be showing you here. Okay, so let's look at our first one. It says y minus 6 equals 18. Now I'll be showing you some major steps that later we modify a little bit, make little shortcuts, but here we're going to show pretty much every step, everything we do. So we want to isolate the y on this side. So what do I have to add to a negative 6 to make it go away, or a 0? And you might say, well, it's additive inverse. It's opposite. So what is the opposite of negative 6? Well, a positive 6. Now, in order to keep this an equation, I have to add 6 to this side as well. So now this cancels out and we get a y. And we add 6 to 18 and get 24. We started off with something on this side. We wanted to isolate the, in this case, the y, and eventually have it equal the number. So a very simple thing. Now, sometimes the t or the letter will be on the other side. That's okay. We want to get the t by itself. So what do I add to a negative 5 to make it a 0? It's additive inverse. It's opposite. But if I do it to one side, again, I must do it to the other. And I would strongly recommend this technique to do it. Here, this is going to become a 0, and we get a t. And then this becomes a, let's see, positive 5. How about a negative 13? And that is your solution. Now, whether you have decimals, that's fine. Want to get the y by itself? What's the opposite of this? Well, a negative 8.1. A negative 8.1. So we get y by itself equals, now we subtract, this is going to be 8, and this is going to be a 5. So y equals 5.8. Now, for something like this, there are other ways to do these sometimes. We'll just show you what's here. We want to subtract 2/3 from this side. Now I'm going to do it this way here because I have to get my common denominators here. Here I know that's just going to cancel out. But my common denominator is 12. I had to multiply this by a 3, so this is going to be negative 9. Multiply this by a 4, so this is going to be a negative 8. So I get here, and I'll write it up here because I ran out of room, a equals a negative 17 over 12. And the technique I used was to add the additive inverse to make whatever was with the a 0 to both sides. Okay, let's clear that up. You can actually raise it up a little bit. Now, in example 1, what we were doing is adding something to both sides. Well, sometimes the x is not by itself. So in a case like this, we look at the numerical coefficient of the x, and we divide by that. That's a 2. So we're going to divide by 2. That will leave me on this side with just an x. But I have to divide that side by 2 also. X equals negative 9. Again, we're thinking of that scale in which it was balanced, and we're doing things to both sides to keep the scale balanced until we end up with just a 1x, x equals something. Now here we're going to go into our box of tools. We want this to be a 1x. So when we have a fraction like this, how do we make this fraction a 1? Well, the answer was to multiply by its reciprocal. But if we do that side, we must do this side too. So here it all cancels out, and we end up with a 1x. That's why we chose the reciprocal. Now here 2 will go into there once, 2 will go in there 6 times. 3 times 6 is 18. That's our solution. Now again, we want to get just a plain x here. So if we multiply this by 3, and this side by 3, here the 3's cancel out, and we get a 1x, and this is a negative 24. Now, this is a good example of techniques that we've been developing. Here we have a negative x. We want that to be a positive x. Well, one of the tools we have is that we can divide this by a negative 1 and the other side by a negative 1. Notice what happens. Negative divided by a negative makes it a positive. So we always want to solve for a positive variable, in this case an x. Now we have 15 divided by a negative 1 makes this a negative 15. Now there is a little shortcut here. If you see something like this, just change the signs. A negative becomes a positive, and the positive becomes a negative. But really, in the background, what you are doing is dividing each side by a negative 1. That's the shortcut. Now, as we delve into more and more complicated equations, let's raise it up a little bit. We start to use many of the techniques we had in earlier sections. So for instance, keep in mind that what is on the left here is an expression. What's on the right is an expression. But because of this equal sign, it's an equation. So when we have just an expression, we want to simplify it. When we have an equation, we want to solve it. So we start solving it, and I'll use some of the room up here. This is going to be 8y plus 16. This is going to be 4y minus 12. Now the rule is you want to get all the letters on one side, all of the numbers on the other side. And you want to try to keep your variable positive if you can. So what I'm going to do here, I'm going to subtract 4y from this side, and I must do the same to the other. So this becomes a 0. This becomes then 4y plus 16 equals a negative 12. So I eliminated the parentheses, and then now I'm starting to move or to get all of the letters on one side and numbers on the other. So how do I get rid of a positive 16? Well, I have to subtract 16 here and subtract 16 there. So this will become a 4y now all by itself, and this becomes a 28, a negative 28, because that's a negative 12 and a negative 16. You have to be careful about the signs. Now notice, and I'm kind of jammed for room here, but theoretically what you should have done is written this first equation down, then this underneath it, then this step, and then now you're at this step. Now you have 4y equals a number. You want to get y to be by itself. So we're going to divide usually by the numerical coefficient of the variable, which is 4. We then get y equals a negative 7. Okay. Now for letter B, what we do here is we want to collect like terms. So I'll put it up here too because we don't have a lot of room. 10x equals, now I have a 1x and a 4x. This will be 5x plus 20. I want to get all my x's on one side, so I will subtract 5x here and 5x there. This will leave me with 5x equals 20. Now what do I do to get the x all by itself? I will divide by the numerical coefficient, and I get x equals 4. Now if I put my 4 back in the original, it should check. So let's try it here for a moment. We said here x was equal to 4. So 10 times 4 equals 4 times 4 plus 20 plus 4. So this is 40 equals 16 plus 4 plus 20. So 40 equals, this is 20 plus 20 is 40. Yes, it checks. Now as you do your practice, you'll be putting your answer in, and it's going to tell you if you're right or not. And by keeping good records of what you have done, the series of steps to solve the equations, which should be orderly and neat, you can possibly see where you've made an error. Okay, let's go on to letter C. Now letter C, as you look at it, you have to combine like terms. So this and this will leave me with a negative 2z and a plus 5 on this side. And this is going to be a negative 3z plus 10 on that side. So this is often considered the intermediate step, where you have a variable and a number, a variable and a number. You can't combine any terms, there's no parentheses. So now what you want to do is get all of your letters on one side and trying to keep your letters positive. So what would you do here? Well, I would add 3z to both sides. So this leaves me with a z there. I will then subtract 5 from both sides right here. And it's important to keep track of your signs. And then z equals 5 for this one. And over here again we have to combine. This is going to give me just an x plus 4 equals, looks like it's going to be a negative 13. I'm going to subtract 4 from both sides to isolate the x. X equals a negative 17. Again, you can try these, and you will be trying some similar to this in your practice as you go for mastery. Let's raise it up a little bit, because we'll get to our answers here too very shortly. Okay, there they are. And I haven't checked the answers, but hopefully we're doing okay. All right, now, this one is very crucial because there are lots of fractions. And we want a technique that will allow us to get rid of all our fractions when we have an equation like this. Now the rule is multiply each term in your equation by the least common denominator. So right now our denominators are 6, 3, another 6, and a 2. So what would be a number that would be the least common denominator of all of these? And the answer is 6. So there's a couple of ways to do this, but I'll do it this way. We're going to multiply each term by 6. And it's each term So here the 6's cancel out, and I'll write it over here. We're left with a negative x. For this one, a negative x. Now here, the 3 will go once, into 6 will go twice. So there's a little negative there. Negative 2 times 1 is negative 2. Now here the 6's cancel out, and we're just left with a 5x. And here the 2 will go once, it will go 3 up in there. So we now have 3 times 1 is 3. So there's our new equation. It's not the same, but it's equivalent. We multiplied every term by 6. So we kept the balance, but it's much easier to work now with no fractions. So I want to keep my x's positive. So I'm going to add 1 here. And I'm going to add 1 there. And you got to watch the signs. So here this cancels out. I'm left with a negative 2. This becomes a 6x, and this becomes a 3. Now I want to get rid of the 3, so I get the x's by itself. I'm going to subtract 3, yeah, not 6. Subtract 3. So this cancels out. I now have 6x equals a negative 5. I'm going to divide both sides by 6 now. I get x equals a negative 5, 6. And we see that right over here, down at the bottom. Again, the first thing you want to do is determine what was your least common denominator. That would, if you multiply that by each term, would leave all your denominators as a 1. So get rid of the fractions. And that's what we did. Another way to do this, and they show in our textbook, is just to put a big bracket here and put the 6 out there and do each one as you would like in distribution. But another technique is this. Okay, number, or letter F I should say, is just tedious. But notice all these decimals. Well, another technique along with fractions is that you change each item so you get rid of all the decimals. Now, what would I need to multiply this by to get rid of a 0.9? And the answer is you multiply it by 10. That will move the decimal place over 1 place. So this becomes then a negative 149. Now I have to multiply this by 10. There is no decimal, but that's all right. I just make it 40. Multiply this by 10, makes that a negative 27. Multiply this by 10, that makes it a 20a. Multiply this by 10, it's 51. Multiply this by 10, that's going to be a plus 70a. And multiply this by 10, that makes it a 15. And you might say, what's the advantage of this? Well, now I don't have to worry about having the decimal in the right place. So again, you're going to collect like terms, and then eventually when you do solve it, and this is getting a little long, it's going to become a is 11. So if you want to work that, you can, but we'll keep it a little bit short here. Okay, write each algebraic expression described. Two numbers have a sum of 72. If one number is z, express the other number in terms of z. All right, for this I'm going to show you something hopefully that's going to be very useful to you. I'm going to say this box has a value of 72. And there are two numbers that this box is divided into that when they're added make 72. Now if it was 50 or 25 or 500 or 135, it would be the same technique. This box represents the total. So I'm going to put a line right here. Now I'm going to say one of these numbers is z. This part is z. Now, what would the other part be? Well, we know it was, if the whole box was 72, if we take away the z here, this is the other part. So we're designating part of that box as some unknown letter, then always the other part would be the total of the box minus that unknown letter. And that's the answer to letter A. During a recent marathon, Tom ran 8 miles more than Judy. If Judy, this is Judy, she ran X miles, how many miles did Tom run? Well, he ran what Judy ran plus 8 more. So this is the amount that Tom ran. This is the amount that Judy ran. And again, some of these you need to think about and often reread, try to understand it. On a recent trip, Raymond drove X miles in one day. On day 2, he drove this many miles more than he did on one day. So he had this much from the other day that he drove, plus this much more. How many miles in terms of X did Raymond drive for both days? Well, it's going to be X for the first day, plus what he did on the second day, X plus 170. Now, this is in its spread out form. We want to simplify this. So the answer would be 2x plus 170. I believe that's what they want. Yep, right down there. Okay? Now, if you put it in MATLAB this way, again, they're not going to accept it. They wanted it simplified. Okay. Well, a few quick student-teacher notes here. Like terms. We have to combine like terms. And again, organize your work. Be careful as you set it up. Here I'm not giving you too much of a good example because we're using this page and it jams it up a little bit. But you want to lay it out. This equals that. Next step, a little shorter, this equals that. Next step, this equals that. And then finally, x equals 3, or whatever the answer is. Notice our equations are orderly and the equal signs are lined up. This is what we're looking for.